Hi, I'm Vanessa Garza. I'm part of Group 14 and I hope you enjoy the video. For the first problem, to find the difference quotient for the equation f of x equals negative 5 x to the third plus 2x, you would use the equation f parentheses x plus h minus f of x divided by h. So first you would need to write down the original equation, substituting dx with x of x plus h. Since it would be negative 5 parentheses x plus h to the third power, you would need to multiply x plus h 3 times. You would then distribute the 2 into the x plus h, getting 2x plus 2h. First, you will multiply the first two x plus h, and you would get x squared plus 2hx plus h squared. Next, bring the h plus x down and the 2x plus 2h. I realized that I messed up there and it was 2h. Yes. Next, you would then write negative 5 again, but then multiply the x squared plus 2xh plus 2h squared times the last x plus h. So you'd get x to the third power plus hx squared plus 2x squared h plus h squared x plus 2x h squared plus h to the third power. Next, bring the 2x plus 2h down. Next, what you need to do is bring down and combine all like terms. So it would be negative 5 parentheses, and since x to the third power is by itself, you would just keep it there and bring it down since you can't combine it with anything else. And h to the third power is the same thing. Then you would combine the hx squared and the 2x squared h, and that would make 3x squared h plus, and then you would combine h squared x plus the 2x h squared, and that would make 3h squared x. You close the parentheses and you bring down the 2x plus 2h. Next, you would just write everything down, distribute the negative 5 into everything that's in the parentheses. So it would be negative 5x to the third minus 5h to the third minus 15x squared h minus 15h squared x, and then just rewrite the 2x plus 2h. Finally, you would follow the original equation, which is subtract the negative f of x, which is the original equation, being negative 5x to the third plus 2x. So you'd cancel the like terms on the top and on the bottom. You would then bring down the rest of the equation that's left out and divide it by h. So it would be negative 5, you cancel one of the h's, and it's going to be left as negative 5h squared minus 15x squared, since the h on the top is cancelled, and then minus 15, you cancel one of the h's, hx plus, you cancel the h on next to the 2h, and it's going to be left out as 2. So then you're just going to rewrite the equation. It's going to be negative 15x squared minus 5h squared minus 15h x plus 2.
Hey guys, I'm Alberto Garcia Jr. and I will be doing problem number 2. And in problem number 2, we're going to use the functions fx equals x squared minus 5x and gx equals x squared plus 3x plus 4 to find the first one being a f of g x. So of course we're going to have to write down the first one using the g in every x that the f of x has. So we're gonna plug in the g function for every x that the fx function has. This, of course, means we're gonna put the first x squared plus 3x plus 4 in the first one and square that, and then minus the 5 and then again use it again f, and then minus 5 and then parentheses x squared plus 3x plus 4 again, as you can see right now. This of course means that the function would end up being parentheses x squared plus 3x plus 4 parentheses squared, and then minus 5 parentheses x squared plus 3x plus 4 close parentheses. Now, we're going to have to try to simplify this a little bit more though. So what I'm going to put is the x squared, the x squared plus 3x plus 4, and not square that, but do it again, but multiply it by itself, meaning that I'm going to put another one, x squared, which is plus what I'm doing plus right 4, now, as you can see. But we are also gonna distribute property on the rest of the function, which is the 5x squared minus 15x plus 20. We did this again by simplifying the x squared plus 3x plus 4 squared. So we simply simplified it by multiplying each other by it. So it came out to the x squared plus 3x plus 4 times x squared plus 3x plus 4. And we just simply used the distributive property for the other part of the function, which was the minus 5 parentheses x squared plus 3x plus 4. And that just became the minus 5x squared minus 15x plus 20. Now we're going to have to use distributive property again, but for the first part of the function, which would just come out to x to the power of 4 plus 3x cubed plus 4x squared plus 3x cubed plus 9x squared plus 12x plus 4x squared plus 12x plus 16. I usually leave out the minus 5x squared minus 15x minus 20 and put it into the end so that it doesn't occupy that much space and the line doesn't look that ugly. So, as you can see, I am explaining that throughout the video. For that, now we're gonna just take away the start scratching out, but until after we do everything again, which would be writing down the x to the power of 4 plus 6x plus 17x squared plus 24x plus 16 minus 5x squared minus 15x minus 20. All of this we got once we added and subtracted everything that was on top. Once I put all of that in, I just scratched out what was able to be scratched out from the top one and from the bottom one, which was you have to do it once you scratch something from the top, you have to scratch it out from the bottom as well. And as you can see right now in the video, I started scratching out the numbers, and that is what I'm doing right now. After the scratching out, all you have to do is really combine all the every part of the function that is left, and which is actually not much, because as you can see, there's a lot of things that have been canceled out throughout the function. So right now in the video, I'm just explaining what happened, and what is next is the function what is left of it is just x squared plus 6x cubed plus 12x squared plus 9x minus 4. That would be the answer to the A. And I am just finishing it off here. This is a part when we're just giving each other a thumbs up, my partner Vanessa and I. Now, for the next problem we're going to have to do is problem B of part 2, which is, of course, using the same functions from above, which are fx equals x squared minus 5x and gx equals x squared plus 3x plus 4. And B is asking to use g of f. So in this one, we're going to have to plug in the function x squared minus 5x for every x that is in the function g. So we're going to start it off, and you're going to have to put the first x, which is x squared minus 5x squared, because the function g of x has that in the first x, then plus 3 times x squared minus 5x again, because another x popped up. Then we just add the 4 at the end. After that, now you're going to have to simplify more, and that, of course, you just have to multiply the x squared minus 5x times itself. That's where you're going to use x squared minus 5x times x squared minus 5x, which will come up before the plus 3x squared minus 15x plus 4, which we got from just using distributive property for the 3 times x squared minus 5x. Now, the next step after that would be just using distributive property on the first set of problem set of the function, which would be the x squared minus 5x times the x squared minus 5x. Now, this, of course, Vanessa is explaining as well here. And now, we are messing around a little bit, but now let's get back to work. Now it is x to the power of 4 minus 5x cubed minus 5x cubed plus 25x squared plus 3x squared minus 15x plus 4. Of course, the x to the power of 4 minus 5x cubed minus 5x cubed plus 25x squared is gotten from the first problem of the function, which I already talked about, which was the x squared minus 5x times itself. And the 3x squared minus 15x plus 4 is, we just put it down to the bottom again. So once we cancel everything out, the answer ends up being x to the power of 4 minus 10x cubed plus 28x squared minus 15x plus 4. And I am finishing up writing this right about now. That would be the answer for number 2, part B. And as you can see right now, I just finished writing the answer, just pointing out what we're going to cross off at the end, which will lead us to our answer. And those will, of course, end up being the x to the power of 4, the negative 5x cubed, both of them, and then the 25x squared.
For the second problem, continuing, it would be f of x. So you would use only the f of x equation and put it inside the other one. So substitute every x with f of x. So you would write x squared minus 5x parentheses squared, since it goes back to the x squared on the original equation. And then minus 5, and substitute that x with the f of x, which is x squared minus 5x. Next, you would distribute the x squared minus 5x to multiply by itself since it's squared. So it would be x squared minus 5x times x squared minus 5x. And then distribute the negative 5 into the other equation. So negative 5x squared minus 25x. Then you would multiply and distribute the inside of the two first ones. So it would be x to the fourth minus 5x to the third minus 5x to the third plus 25x, and then bring down the rest of the equation, which is negative 5x squared minus 25x. Then you would just combine the like terms, and it would be x to the fourth since it's the only one, and then negative 5x to the third minus 5x to the third would be combined and would be negative 10 x to the third. The 25x and the negative 25x would cancel, so you would just bring down the negative 5x squared. And so the answer would be x to the fourth minus 10x to the third minus 5x squared. And that would be the final answer. For D, it would be the same thing as C, but instead of f of f, it would be g of g. So you would substitute each x on g of x with the same solution, with the same problem. So it would be x squared plus 3x plus 4 squared, and then plus 3, substitute the x with the equation, so x squared plus 3x plus 4, and bring down the 4. Next, you would distribute the squared into the two equations and make it 2. So x squared plus 3x plus 4, and then multiply again, x squared plus 3x plus 4. Distribute the 3 into the equations, so plus 3x squared plus 9x plus 12, and bring down the 4. So now you would just distribute the equation, and so it would be x to the fourth power, and then plus 3x to the third plus 4x squared plus 9x squared plus 3x squared, x to the third, plus 12x plus 4x squared plus 12x, and then plus 16. You would keep the 3x squared plus 9x plus 16 on the top so you don't get confused, and just combine like terms with the bottom one and then combine it again. So it would be x to the fourth plus 6 x to the third, combine 4x to the second plus 9x squared plus 4x squared, and get 17x squared. Then you would combine the 12x and the 12x, and that would be 24x. Then cancel them out, and then plus 16. Now you would bring down the other equations that are on the top that we left out, so we can combine those. So just rewrite everything again, and it would be, what was I doing? Yes, I was confusing this part, so I go back to it and then I rewrite it. Okay. At this point, I figured it out. I thought I had the right answer, but then I forgot to bring down that part, the second part. So I bring it down. So I add the plus 3x squared, then plus 9x, and then plus 12 plus 4. And now you're gonna combine the like terms. So you get x to the fourth, and then x to the 6x to the third. Then combine the 17x squared with the 3x squared and get 20x squared. Cancel them, and then combine the 24x and the 9x, get 33x. Then combine the 16, the 12, and the 4 and get 32. And now that was the right answer.
For problem number 3, it is asking us to use the rational root theorem and find all zeros from the function px equals 2x to the power of 4 plus 5x cubed plus 3x squared plus 15x minus 9 equals 0. So the first thing we have to do is get the divide negative 9 by 2 so that we can get the plus or minus 1, plus or minus 3, plus or minus 9 divided by the plus or minus 1 or the plus or minus 2. This would mean that we have to try plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 9, plus or minus half, plus or minus 3 over 2, or plus or minus 9 over 2. This is what my partner Vanessa is writing down right now. So then we're going to have to try all those out, and this is how we're going to use it, using matrices. So the plus or minus 1, we use the matrices, and then we're going to use start with 2, 5, 3, 15, and negative 9, which of course getting from the function above. So we're going to use the plus or minus 1 first, and of course it's gonna come up to 2 in the bottom because the first number just drops down, and then the 1 times 2 to get 2, then 1 times 7 to get 7, and then the 3 plus 7 is 10, 1 times 10 is 10, 15 plus 10 is 25, and then 1 times 25 is 25, and negative 9 plus 25 equals 16x. So that one is not a 0. So next is negative 3, and we're going to of course do the same thing, drop to 2 with the matrices, and then it's going to be negative 3 times 2, which is negative 6, negative 6 times negative 3. That is after we get the negative 1, which comes from negative 6 plus 5. Then it's negative 3 times negative 1, that's 3. And then it's 3 plus 3, that should be 6, but there seems to be a little problem there when copying down. And it should be negative 3 times 6, which should be negative 18. Negative 18 plus 15 should be negative 3. And then negative 3 times negative 3 is 9. And negative 9 plus 9 equals 0. So that is correct. The next one will be the half. And we're going to use a matrix on that as well. So the 2 just goes down. Half times 2 is 1. 5 plus 1 is 6. Half times 6 is 3. 3 plus 3 is 6. Half times 6 is 3. And 15 plus 3 is 18. And half times 18 is 9. Negative 9 plus 9 is 0. So that works out as well. Now for this, we're going to use the half one to plug it into the equation, which ends up being 2x cubed plus 6x squared plus 6x plus 18 divided by 2. And that equals x cubed plus 3x squared plus 3x plus 9. That means that the matrices that we're going to use here is just going to be negative 3. Negative 3 is what we're going to use for this matrices that we're going to use with the following leading coefficients, which would be 1, 3, 3, 9. Okay, so now what we're going to use, of course, again is negative 3 for it. And if we're using negative 3, it's just the first number, 1, is going to drop down, and negative 3 times 1 is negative 3. 3 plus negative 3 is 0. Now negative 3 times 0 is 0, so 3 plus 0 is 3. Negative 3 times 3 is negative 9, and negative 9 plus 9 should equal 0. That means that the function that we get out of it is x squared plus 3. Now, for the x squared plus 3, we're going to use the quadratic formula on that to try to get the other zeros as well. Now, the quadratic formula, of course, once we plug everything in, should be plus or minus square root of negative 4 times 1 times 3 divided by 2 times 2, which would basically end up being plus or minus negative 12 over 4. But that won't be the end of it, because of course you cannot have a negative in the square root. So we're going to have to do plus or minus I times 4 square root of 4 times 3 divided by negative 4. And since 4 is a perfect square root, we're going to have to use plus or minus I 2 square root of 3 divided by 4, but we can cancel divide by 2 to simplify it, which will end up being plus or minus I square root of 3 divided by 2 as our last two zeros. As you can see, I just finished that. So all of the zeros would end up being the half, the negative 3, and the plus or minus I square root of 3 over 2 for those last two zeros, of course. That will be the end of this problem. Thanks for watching. See you again next time.